Hello everyone, so today I'm going to be making a video on the probability of missing every single one of these shots whilst playing Battleship. So this screenshot actually comes from my friend, so I just wanted to work out the chances of this happening. So first of all, there were 23 missed shots and the board is a 10 by 10, so there's 100 total squares to hit. And the ships take up 17 squares, so that would mean that there are 83 blank spaces basically. So the first thing I'm going to do is work out the probability of missing one shot, which would be 83 over 100 because of the 83 and the 100 here. Hopefully that's fairly straightforward. So then missing two shots in a row is going to be this multiplied by 82 over 99 because, like, say it was this shot that I hit, for example, and then with the rest of the space, there's only going to be 99 other squares to hit, and 82 of those will be blank spaces. So if I keep on going like this, it's going to be times 81 over 98, and so on. And because there's 23 misspaces, I'm going to take away 22 from the starting value here, because the starting value I take away 0, which counts as a value. So I'm going to do 83 minus 22, which is 61, and then I'm going to do 100 minus 22, which is 78. So hopefully that makes sense, but this may be a bit hard and long to do in the calculator, right? So I'm going to simplify it a bit by putting it into a series. So if I draw sigma here, my starting value is going to be 0, and it's going to go up to 22. So there's 23 in total, including the 0. And I'm going to rewrite this as 83 minus r all over 100 minus r. Because then when r is equal to 0, it's this value, and then when r is the last value, it's going to be this. So then you may be a bit confused as to what I'm doing with this. So I'm actually going to turn this into factorials, because basically what this series is doing is it's doing 83 minus 0 over 100 minus 0 multiplied by 83 minus 1 over 100 minus 1. It's just this, basically, right? So I can simplify that by doing 83 factorial divided by 60 factorial, because that basically cancels out any of the lower values here, like anything less than 60, because 61 is the lowest it can be here. So then this top is basically just 83 times 82 all the way to 62 times 61. So then I'm going to do the same thing on the bottom. So this is going to be 100 times 99 times all the way down to 78. So because we don't want to cancel out the 78 here, we're going to write 100 factorial divided by 77 factorial. So then that only gives these values here. So I've just rewritten the this fraction as like this. So then I can do my keep change flip from GCC on this. So it's going to be equal to 83 factorial times 77 factorial all over 100 factorial times 60 factorial. So now I can start cancelling things out. So as 100 factorial goes all the way from 100 to 0, I can basically cancel out all of the vectors from 83 factorial. So I would be left with 100 times 99 times ... all the way to 84, because anything 83 or less gets cancelled out. So then this top is just going to be left with 77 factorial, and I've still got the 60 factorial left here. Then I'm going to cancel out the 60 factorial with the top one. So I'd just be left with 77 times 76 ... all the way to 61, because I cancelled out 60 and all of the factors less than that, and then I'd just be left with the 100 times 99 times ... times 84. And I'm pretty sure that's the simplest you can go. You're welcome to prove me wrong in the comments, but that's what you end up being left with. And then if you end up plugging this into your calculator, you get 0.0073776 and so on. And then if I multiply this by 100, it's going to be 0.738%. And there we go. That's it. So if any of you have any other problems you want me to solve, then feel free to let me know. But yeah, that's it. Bye bye.